welcome to the Explainer. So let's jump right in, because today we're looking at an absolutely monumental paradigm shift in tech and math. For years, we've thought of AI as this really fast assistant, something that just reads what we've already written and kind of summarizes it or writes code we already know how to build. But guys, that era, it's officially behind us. We're looking at a massive breakthrough where AI has evolved from just summarizing our data to actually generating completely autonomous, net new knowledge, stuff no human has ever uncovered.
Which brings us to this massive, honestly fascinating question. What happens when artificial intelligence stops summarizing what we know and actually starts discovering what we don't? It sounds totally like science fiction, right? But it just became documented reality. To wrap our heads around how we cross this threshold, we got to open up a really cool mathematical mystery box. We're going to look at an unbreakable 80-year-old math riddle that totally stumped generations of the smartest human minds, and we'll see exactly how machine reasoning cracked it wide open.
So, Act 1, the connect the dots enigma. Our story actually starts way before modern computers even existed, with a deceptively simple spatial puzzle. Back in 1946, the legendary mathematician Paul Erdős posed the Planar Unit Distance Problem. Armed with just a blank sheet of paper and a 1-inch ruler, your goal is simple: place dots to maximize the number of pairs that are exactly 1 inch apart. With 2 dots, easy, you get 1 pair. 3 dots, you form an equilateral triangle, yielding 3 pairs. Now, here's the absolute crucial part: the n equals 4 dots benchmark. To maximize the pairs here, you join 2 equilateral triangles together, forming a diamond or rhombus shape. This gives you exactly 5 unit distance pairs, and I want to be incredibly precise about this. That is exactly 5 lines of 1-inch distance connecting those 4 dots, not 6. The diagonal right across the middle, that isn't 1 inch, so it doesn't count, just 5 precise lines.
Pretty easy on a small scale, right? But Erdős didn't just stop at 4 dots. He asked the world a staggering question. As you add more and more dots, hundreds, thousands, or even scaling it all the way up to infinity, what is the absolute maximum number of 1-inch pairs you can possibly create? It sounds like a fun little geometry game, but this exact question caused an 80-year mathematical traffic jam.
And here's exactly why humanity got stuck. We totally fell into a trap. For nearly 8 decades, the consensus among mathematicians was that the absolute best way to pack these dots together, to maximize those exact 1-inch connections, was to arrange them in a dense, tightly packed square grid. Think of it kind of like a window screen or a regular sheet of graph paper. Humans couldn't calculate the perfect, exact limit for an infinite number of dots, but pretty much everyone in the field operated under the strict assumption that this square grid was the absolute pinnacle of geometric efficiency.
In the scientific world, we call something like this a false ceiling. It's a deeply entrenched consensus or assumption that creates an invisible, unyielding barrier to progress. Because every mathematician just assumed the square grid was the optimal base layer, they spent 80 years basically trying to tweak and optimize within that specific box. The grid hypothesis literally trapped generations of brilliant human minds in a traditional planar geometry framework. They couldn't see past the grid because, well, they trusted the grid.
Which leads us to Act 2, the break, where AI completely shatters the grid.
So what happens when you introduce a mind that doesn't carry 80 years of human bias? Well, when OpenAI's reasoning model approached this problem, it did something truly awe-inspiring. It didn't even try to optimize our human square grid. No, the AI completely discarded it. It looked at this 80-year-old framework not as a boundary to be respected, but as an obstacle to destroy. It simply wasn't constrained by decades of traditional geometric reliance. It went looking for a hidden trapdoor that humanity had basically just been walking right past for decades.
But the absolutely crucial point here is how the machine did this. Looking at this comparison, you can really see the shift in fundamental mechanics. On one side, we've got the human method, traditional planar geometry. That's essentially tweaking spatial arrangements on a flat, two-dimensional surface with a compass and a straight edge. But on the other side, that's the AI's brilliant pivot. The model uncovered a hidden family of patterns by attacking this spatial puzzle through incredibly deep algebraic architecture. It utilized concepts from a totally different branch of abstract math called algebraic number theory. The AI realized, hey, this isn't just a geometry puzzle, it's actually an algebra puzzle in disguise.
And by making that mental leap, the AI achieved a massive, historic result. It formally proved that humanity's best guess for the last 80 years was simply too low. By completely shattering that 1946 limit, it unlocked an entirely new pattern family that allowed for way more exact 1-inch connections between dots than the old grid pattern ever could. That previous ceiling was entirely invalidated by this brand new algebraic arrangement.
All right, moving into Act 3, overcoming logical fatigue.
This really begs the question, why couldn't human mathematicians, literally some of the smartest people to ever live, see this algebraic trapdoor? Well, this graph perfectly illustrates the core biological difference. As human researchers, we often have to abandon impossibly long, complex chains of logic. When you're doing really deep mathematics, eventually you just hit cognitive fatigue. Or, let's be real, you just run out of coffee. You assume a certain path is a dead end simply because the mental bandwidth required to keep exploring it is just too exhausting. But the AI, it possesses infinite logical stamina. It doesn't get tired, it doesn't need sleep, and it marches right through that exhaustion zone, pursuing those incredibly complex, seemingly endless chains of logic until a breakthrough is actually found.
Let's walk through this clean data comparison really quick, because it definitively juxtapositions our two frameworks. Under the 80-year human tradition, the core assumption was that the square grid is optimal. The method was refining known heuristic patterns using planar geometry, and our limiting factor was cognitive fatigue and a natural adherence to conventional wisdom. The AI paradigm completely flips all of this. Its core assumption was that the grid is a false ceiling masking deeper efficiencies. Its method, unconstrained structural discovery from scratch using deep algebraic number theory. And its limiting factor? Well, there essentially isn't one, because it relies on exhaustive algorithmic processing with infinite stamina and a complete 100% lack of human bias.
And that brings us to Act 4, the knowledge horizon.
We really need to zoom out from this specific math puzzle for a second and look at the macro implications this breakthrough has for the entire scientific landscape. It completely builds our understanding of AI's evolution. Up until very recently, we were at step 1. AI is a synthesizer. It just summarized text we humans had already written. Then, we pretty quickly moved to step 2. AI as a creator. Think generative art or audio based on analyzing existing human patterns. But the resolution of this Erdős puzzle marks a permanent inflection point. We've officially crossed the threshold into step 3, AI as a discoverer. The machine is generating autonomous, completely original, net new mathematical truths that no human in history had ever uncovered. It is actively adding to the total sum of human knowledge, not just reorganizing it.
And this is exactly why the math world is celebrating this proof so much. It's not just about getting the right answer to a niche geometry game. It's entirely about the method. As this quote captures so perfectly, the AI didn't just calculate faster, it acted as a creative partner, looking at an old puzzle from a completely fresh angle and finding a hidden trapdoor. It proves for sure that artificial reasoning can now actually partner with human curiosity to explore the absolute limits of logic. We are no longer working alone out there.
So I want to leave you with this provocative final thought to ponder. We've seen how a false ceiling in mathematics was completely shattered by infinite machine stamina and unconstrained structural discovery. Now that AI has crossed this threshold into autonomous mathematical discovery, what other 80-year-old assumptions are we currently blind to? What hidden trapdoors will this technology find next in the fields of physics, medicine, or engineering? The grid has been shattered, guys, and the horizon of discovery is completely wide open. Thanks for joining me on this explainer, and keep questioning the grid.